Hi, I'm Dave Carnegie. I'm an environmental engineer, and today I'd like to talk to you about excess soil and the importance of engineers working across disciplines to find solutions. Excess soils are a big topic, too broad to properly cover in the limited time we have in this ENGtalk. What you need to know about excess soil today is that excess soils are soils that cannot be reused within a project and so must find another home. In 2015, the Residential Civil Construction Alliance of Ontario, RCCAO, estimated that 20 to 25 million cubic meters of excess soil are generated each year in Ontario. You should also know that there is a new regulation, OREG 40619, and associated rules document that were filed at the end of 2019 to provide greater clarity around when soil is waste and when it isn't. This was done to try and reduce the amount of relatively clean soil going to landfill and to reduce dirty soil from ending up in places it shouldn't, like agricultural settings or in sensitive rural settings where people rely on private wells for their water supply. The new regulation will come into force on January 1st of 2021, but elements of the regulation and rules will be phased in over time. You might be asking, isn't all soil dirty? It depends. Ontario has chemical standards that we use to evaluate potential harm based on toxicological models and considering different site settings where a given quality of material might end up. The standards are intended to ensure that people, plants, and animals are protected and are rooted in other regulations and best practices related to the remediation of contaminated sites. Those familiar with the Brownfields regulation, OREG 15304, would recognize tables 1 through 9, which represent generic soil quality standards for commonly encountered settings. These tables were developed for contaminated sites and assumed a finite quantity of soil with a given contaminant, 350 cubic meters to be exact. Complementary volume-independent standards, tables 2.1 through 9.1, were developed to evaluate soil quality for volumes in excess of 350 cubic meters. And these are described in the excess soil rules document. Like the contaminated sites regulation, there are also options to modify site condition standards by considering regional background soil quality or through risk assessment. The Ministry of the Environment, Conservation and Parks has introduced a beneficial reuse assessment tool that we call the BRAT that works a lot like the Modified Generic Risk Assessment, MGRA model, and can be used by practitioners to derive alternate soil quality standards for receiving sites that are protective and based on the specific features and controls of the receiving site. Soil exceeding standards can cause physical harm and can cost everyone a lot of money to reduce the harm. Some generators of excess soils are more cautious, and were sending all soil to landfill, even if the risk of harm was low. Well, this sounds good on paper. Landfill disposal is relatively expensive, uses up valuable landfill space. When was the last time your municipality opened a new landfill? And trucks were traveling long distances to reach landfill sites with capacity, which increases greenhouse gas emissions and wear and tear on our roads. OSPE has held a prominent role in contributing to the evolution of excess soil best practices and policy. In 2016, OSPE authored a paper in partnership with the RCCAO and Greater Toronto Sewer and Water Main Contractors Association on excess soil management. Ontario is wasting a precious resource. This paper captured a snapshot of 24 projects, cumulatively valued at $330 million. And it estimated that handling and disposal of soil represented 14% of the project costs, and cumulative one-way travel distances of more than 200,000 kilometers to dispose of the soil, which generated approximately 300 tons of carbon dioxide emissions. The paper estimated that if soil had been beneficially reused rather than managed as waste, an average savings of 9%, or $30 million, would have been achieved. The paper pointed out that Ontario had approximately $160 billion in infrastructure investment commitments over a 12-year period, and estimated that if the same 9% in savings were applied, the government would save $14 billion that could be redirected to other priorities. OSPE has continued to serve on government engagement groups, providing advice on the new excess soil regulations, and continues to work in partnership with the government and others to develop new guidance documents and best practices for the management of excess soil. The new regulations and rules are intended to shift our mindset to think of soil as a resource, something of value, rather than something to be thrown away when we are done with it. We don't think twice about regulating other resources like water or the air we breathe. Soil helps to protect our water resources, grow our food, and gives us a surface to live, work, and play on. The excess soil regulations and rules create greater clarity around when we can reuse soil safely, hopefully encouraging more local reuse, and perhaps even at some point encouraging the market to increasingly take soil that is a little bit impacted and improve its quality so that it can be used in a greater number of settings. The interesting thing about managing excess soils is that successful management requires coordination with and innovation by professionals that have typically had no or limited involvement with how we characterize and manage soils from an environmental quality perspective. Consideration of soil quality has typically been the realm of engineers, geoscientists, and contractors that specialize in characterization and remediation of contaminated sites. Our experience thus far is that most excess soils are generated during development of infrastructure projects like highways, buried in sewer and water lines, light rails, subways, and residential, commercial, industrial developments. Projects that employ a lot of engineers and a lot of individuals that work with engineers, like architects, contractors, trades, developers, and government agencies. Recall that excess soils are soils that cannot be reused within a project, and so must find another home. If we flash back to our education about the 3 R's, reduce, reuse, recycle, in that order, the best way to solve the excess soils problem is to reduce their generation in the first place. This may mean different ways of designing projects for civil and geotechnical engineers. It may mean different ways of planning projects and designing communities. It may mean new techniques for excavation, handling, and tracking of soil material. In short, we need to think about the whole system that results in the creation of excess soil, and all of the folks that are a part of that system need to work together to create the innovative solutions that we will need. Engineers tend to be proud problem solvers and team players, but my involvement on various excess soil advisory groups and projects has made me reflect on how little we form problem-solving teams with those outside our area of practice, particularly from the lens of an engineer that spends most of his time working with contaminated sites. Maybe some of you have the same observation about your practice. My sense is that cross-discipline, cross-specialty problem-solving is a challenge in many professions. The demands of trying to be better at what you do lead you down a path of specialization where you spend more time talking to other specialists and sometimes forget the value of spending time with professionals outside your day-to-day practice. to discover new ways of solving problems and new ways of working together to make a whole system better. In my field, when we do team up with others, we often work on our own individual pieces and rarely have the opportunity to collaborate with designers that will do work before or after us. While this may not always be necessary, I wonder if there are missed opportunities to create better solutions. For example, rather than doing a site-wide cut, designers can work to keep more soil on-site. Or engaging an environmental engineer at an earlier stage may assist in better understanding the quality of the soil, which can also inform design choices. To use another example, environmental engineers spend a lot of time figuring out how to address chemicals that have ended up somewhere they shouldn't have. Sometimes this is because someone developed an awesome new product designed to last forever, but didn't intend for that product to end up in our water or our food chain. Sometimes this is because a chemical needed to be contained, but the method of containment failed, or because of a material or construction choice. Sometimes the impacts are the result of choices made in our built environment and the diminished capacity of our natural world to mitigate impacts. Whatever the cause, engineers almost always play a role in identifying the failure modes and solutions, whether that be directly through our design choices, or innovating new ways of doing things, or indirectly by educating policymakers to improve standards. Engineers are better when we work together to evaluate an entire system, each contributing insight on the components of the system we have expertise in. When we work together, we are able to identify more complete solutions and educate those that we work with and ourselves about other ways of solving a problem. So how do we improve sharing across our specialties? My ideas are through continuing professional development. Perhaps take a course outside your specialty and see if you discover a new tool or way of approaching a problem. Or perhaps our profession needs a conference or a journal that isn't specialty specific, but attempts to address bigger picture questions and solutions. By having conversations amongst ourselves, we can help organizations like OSPE and PEO create opportunities and guidance that elevate the practice of engineering and ensure that we are getting a broader cross-section of specialists engaging with policymakers. What are your ideas? We would love to hear them. Send them to ambassador@ospe.on.ca.